Free.
Okay, everyone. Well, welcome again. I'm here. I'm Randy Marek. I'm here to talk about data acquisition, recovery, which includes inspection from post-flight. I've done this for the last couple of years out at Spaceport America, and it's been a very interesting challenge. Okay, so what we're going to talk about is what is the basis for this activity, the
Randy,
requirements.
let me jump in real quick. You're not sharing your desktop today.
Oh, shucks. I thought I did. Why doesn't it read your mind?
That's the next version.
Okay, there's share my desktop. Share. Go to.
There we go.
Now is it sharing?
Sure, looks good. Randy, you may want to start everybody off with while you have data acquisition and recovery. Uh, Walk them through a scenario. They may not even understand what that means. What
Okay.
is your role at the company?
Okay. In the past, I've been 30 uh, recovery post-flight inspection. The job is to take y'all bring the rocket in after you return your tracking packs, and my team inspects the rockets to see if they meet the minimum requirement for a successful flight. The minimum requirement for a successful flight is that if, and I can jump into here. Um, I'm gonna,
I'm sorry,
there.
Randy. I'm messing you up. I was just at a real
It
high
doesn't matter.
level. Okay.
No. So sometimes you just have to go with the flow. So, and what we do is, first thing we do is we inspect the rocket. We want to check it to see if there is anything that's happened during the flight that would keep the rocket from flying safely again. We look for airframe damage, fin damage, nose cone damage, damage that may have, which all could have occurred during flight or it could have occurred at landing. The things we don't count against you is if there's a lot of wind out at Spaceport America, and when the rocket lands, it can be dragged across the Savannah ground, and it can cause damage too. So damage to the airframe caused by dragging usually has skid marks on the paint, and it will ding and ping the airframe. Well, we won't count that against you. We have had one team in our recent history that landed on power lines. We won't count that against you, and we will figure out how to get your rocket inspected from afar and safely. With the updated rules that have been uh, brought out, we now allow, if your design allows for quick replacement of a broke fin or damaged fin, that will no longer count against you. The scoring is very simple. It's pass or fail. Either your rocket can be refueled, a new motor loaded in, parachutes repacked, energetics replaced, uh, COTS and other altimeter and electronics reset and ready for flight, and that you can fly again. That is the simple definition of what a successful flight is. If you do that, you get a passing score. If you don't meet that, it's a failing score. So how does this requirement tie back into the rules of Spaceport America Cup? So if you go to the Intercollegiate Rocket Engineering Competition Rules and Requirements, section 2.5 and 2.6, and the competition design test and evaluation guide, section 6, uh, it will tell you, it will then in section 6.8 tells you about redundant electronics, 6.9 about redundant COTS, recovery equipment, and then appendix A, acronyms, abbreviations, and terms, and that is where the term excessive damage is defined. So what are those first two sections? So 2.6 is the requirement for official altitude logging. The logging will be based on barometric pressure altimeters only. The data has to be stored on board the COTS altimeter or its slave card, and it will be used to provide your official altitude for judging how close you come to your goal of either 10,000 or 30,000 feet. The COTS altimeter may be a standalone project like a Telemega or a Telemetrum or a Perfect Flight or any of the other ones that are listed in the standards, and they can also be used to launch vehicle recovery system deployment. If you have a payload in the launch vehicle, the official altitude logging system must be mounted in the launch vehicle, that is the rocket, and not in the payload. So it's a very fine point. So your altimeter tracking altimeter has to be in the rocket itself, not in your payload section that is required under other sections of the ESRA rules. Now, where does the requirements for returning to the MCC and post-flight? Well, under Section 4, it breaks down into the mission manager. That would be one, or myself or one of my team members will record the measured apogee of the rocket based on your altimeter, and it will be used to determine the altitude your rocket flew. If you're using a two-stage rocket, then only the sustainer will be checked for altitude. The mission manager will make certain that the rocket is not excessively damaged. And here, the definition of excessively damaged, as we talked about, is defined as any damage to the point that if the rocket flies again after you replenish all of the consumables, it will do so safely. And in turn, intended consumables refer to normal things such as replacing a motor, replacing the fuel grain in a hybrid, replacing the nitrous, replacing energetics. And this definition includes the ability to replace damaged fins if they are designed for easy and rapid replacement. So when you get ready to come to the inspection portion of the program, you have to bring the rocket, all of its parts, so that we can inspect them. The rocket needs to be free of unspent energetics, ejection charges that may not have fired, no unburnt pellet grains or fuel grains or oxidizer. The tools required to provide access to the COTS altimeter, and a laptop, tablet, or cell phone with all the cables, dongles to interface to the COTS altimeter, the software that is required to be able to communicate with the COTS altimeter so that we can extract the flight and GPS data. In the past, over the years, when this was not well defined, teams would show up and they would not have any tools to remove the altimeter. They did not have the cables necessary. There was a miscommunication as to what information was to be, what tools and everything to be provided. And since we don't know everything you have, and we can't have one of everything, it was a whole mess. So it's upon the teams that are coming, teams to bring their own tools and then means to be able to download data. So as I said, when we do our inspection, we look for anything that keeps the rocket from flying safely. We and then again, and we will worry about that. When you go to data acquisition, the way that works is we will witness the downloading of the flight data from the altimeter. We will then view the data on the computer, tablet, or cell phone with the units of measurement for altitude clearly displayed. We will not count beeps to determine what your maximum altitude is. There's too many different styles and ages of altimeters with too many variances, and since we don't know them all, we cannot fairly sit there and make good determinations of what your max altitude is. Once we confirm the altitude and for the apogee, we talk with your team representatives. We will record the apogee on the team flight card, and then we'll record it in the ESRA database. After that, we are going to save your altimeter's data into the ESRA flight record storage system. So if there's a question during judging, the judges will have the ability to go back and look at things so that we can give everybody a fair chance to do their best and get the highest score possible. It's a really fairly simple process, but some days, on average, for y'all to come in, make certain it's safe, take the rocket apart, do the actual inspection. To do the actual inspection takes from 4 to 8 to 10 minutes. We look at the motor section, the payload section, the parachutes, the shock cords, the nose cone, the avionics, make certain there doesn't appear to be any damage. And then we go through and we will then have you, that's when we have you hook up your interrogation, your laptop, and then start downloading the data so we can see it. And the whole process can take about a half an hour by the time a team has to take their rocket apart and then gather up everything and move on. So being prepared and having everything you need to make this quick, simple, and easy on y'all is what helps us be more successful and get people through the system as fast as we can. Sorry. So that brings me to the end of this. It's really a very straightforward process. So I'm more interested in your questions to help y'all understand what we're doing.
All right. I put out another comment to everyone regarding some questions. You could please include those in the Q&A tab, and we'll look to Randy those as possible. Everyone's tired. Oh. I understand that.
What's that?
Everyone's tired. It's a long day.
Well, yes, that's understandable.
Hey, just put something in the chat. Let us know you're still there. We've got quite a few attendees that are still out there.
Nothing like being brilliant or baffling.
Yeah, what were some of the big problems that we had last year, Randy? I mean, obviously the teams were showing up to the data recovery stint. They didn't have the tools they needed. They did or did not always have the parts. We have a question here. All right, so Max is asking for an altimeter like the Marsa 33 that can have a digital screen attached. Would that count for determining the altitude of the rocket?
It does allow us to view what the what the apogee was, but we still want to be able to download the data. And part of our interest is in the data is there's a long-term study going on to see what our scatter pattern for our rocket landings are. And we need this to help us with working with our insurer of the event, so they understand how well controlled, how well we are at staying within our borders. So it's really important that we get the GPS data also from the rocket, which is now required as part of any rocket. So if you have a separate GPS tracker, then we want to be able to download the GPS tracker also. Does that make sense?
I don't know. Does the Marsa have a GPS built into it? Marsa 33? I'm not familiar with it.
I'm not familiar with it either, but I
Well, I
have
guess
seen
the
it.
short answer is while it's easy to carry around the little LCD stick and plug it in there and get the apogee, the preference obviously is to download the full set of data and the guys will make copies of it for a record. So let's just continue with that. State that the LCD would not be a good option.
Okay.
Good question, though. Great question.
Yeah, and it's a very fair question.
So another question, I guess there are a lot of teams that are out there, and one of the big challenges going to be happening next year is the huge number of teams that we've had. So in years past, I mean, we've had the 2017 event. There was about 80-ish teams that launched over the same time period. We're now for 2021 looking at between 130 and 150. So we're literally almost doubling the number of launches capable teams. And what that does is put a significant amount of stress on the operations, on the inputs and outputs. Teams going out to the pads, everything has got to be extremely well coordinated and efficient. The time frames. If someone's struggling to get their altimeter working when their rocket is on the pad, you can't be waiting 45 minutes or an hour while someone tinkers with it. If that rocket's not working on the pad, that rocket's coming off the pad, and they've got to go back to the safe area, and we'll get another rocket on that pad. We'll be loading two sets of pads while one is launching, the other one will be loading, and vice versa. So it is going to be a constant stream of rockets. The more that we launch in the air and the faster that we launch them in the air, obviously creates a little bit of a train wreck in the back end with teams going out to do recovery. So we're trying to expand that process by adding additional recovery backpacks and more staffing to the backpack recovery team.
Well, and here,
so I want to highlight this with Randy's team can be just exactly the same thing as a similar type of choke point. If you don't have all of your gear ready for the data download process and parts of that, and let me let you know, do not wait till the next day to meet with Randy and his team. You need to be, as soon as you turn in your recovery gear, you need to go to the very next tent where Randy and his team will be there and do that data download. If you show up the very next day, there's going to be a lot of questions about where were you yesterday? How can we validate this real data? So
and this is a real problem. This is a real problem. And requiring that all rockets that fly have GPS trackers on them, this is a safety measure to aid teams to locate their rockets so that they spend as little time out in the field as practical. If you're not used to high deserts, dry areas, people can become physically and mentally overloaded working, trying to walk around in the heat looking for a rocket. And even when you have coordinates, the last coordinate that we have is when the rocket was high enough for the receiving altitude to view it, and that the altimeter or the GPS unit sent out a ping, an APRS packet. So depending on that, it could be anywhere from 50 feet from the ground to 100 feet to the ground, and 100 feet down to the ground. The rocket can go a lot of different directions, which makes it a challenge. And so teams also have to be prepared and work out before they get there on how they're going to do their searches for the rocket based on the GPS uh, coordinates that should be provided by the Mission Control Center. This is a huge improvement for the teams to be able to not only get better data on their rocket, but also to be more efficient and safer while out in the desert trying to recover the rocket.
And one more additional value add built into that is you gain experience working with GPS systems. The ability to do that is something you can throw right in with all the other rocket systems. If you're doing live telemetry, that's one thing, but live telemetry with GPS, and you understand GPS coordinates, tracking, and all that, that goes right on your resume. So that's, again, really valuable stuff that you should be familiar with and be comfortable working with.
Yeah,
Because that's certainly utilized in aerospace to the extreme.
it's used down to our credit cards these days. But the other thing is, whatever your tracking tool you're using, be it an app on your cell phone, a standalone tracker, and given that we are in the middle of nowheres and cell phones don't work, you need to have maps preloaded into your cell phone. You need to have, or your tracker, so that you are not sitting there looking at a blank screen saying you are here and you don't know where here is. So uh, some planning needs to be done, just like in engineering and designing your rocket and preparing for your flight profile. You need to plan the recovery activities in great detail and understand your tools and make certain you have your kit all together.
Finally, there was a session earlier this morning. I don't know if everyone was able to attend it or not. The recording should be available shortly if it isn't already available. That specifically focused in on GPS tracking, the requirements, and how it applies to your rocket project for next year's stuff. It is vital that you understand that the new rule and requirement we implemented in 2019, but for 2022, that'll be the very first year that we are absolutely enforcing it. Your team needs to understand the GPS requirements, and for a lot of the teams that are in the United States, it's really not that big a deal um, to, to to just meet the requirements that is stated in there. For some of the international teams, particularly those that don't have the opportunity to get an amateur license, um, it's obviously something we're going to need to work with. However, more and more of these countries are reporting, and Brandy can speak to this. He is a top level certified amateur radio uh, expert and highly certified in that arena. So in fact, Brandy, tell me your story about where you took your most recent certification exam.
Oh, well, I'm an engineer. I'm a control system instrumentation engineer, and moved up into project manager. And a couple of years ago, I was working on a project for Saudi Aramco, and so I wanted to get my extra license. So I went to, there's a big ham fest in Friedrichshafen, Germany. So I went to Friedrichshafen and took my extra exam there and passed it. And so I now have my extra license. So there are a lot of different ways to get your license, and it doesn't always have to be. I mean, there's a lot, even if you get a license within your countries, and some countries are harder than other countries. Um, it just, and but then we have reciprocity, and it opens doors for you. But and exam for us these exams aren't that hard. The real problem is knowing what answers they want, and there's a lot of very good study guides on available to you online to study for the test, because there's more than one says that, well, the answer has to be this, and I look at their answer and I'm going, that answer's almost right. And but the more, because we know more than the average folk, you're going to find yourself going, well, that's not exactly right, but that's the answer they want. So that's all you need to know so you can pass the test.
In my personal experience, the only reason I got my AM license was not that I talk on long distance radios to other people around the country or around the world. I did it specifically so I could use a high-end altimeter and GPS unit on my rocket project. And
Yeah.
so when identifying that, I was like, man, I got to take it. I got to take it. So I grabbed my 14-year-old son and my 15-year-old daughter, and we studied for an entire week. Uh, just going over the questions, going over the concepts, all that kind of stuff. We studied, Saturday and Sunday, and then we went in on Tuesday to actually take the exam. And the 14-year-old and 15-year-old, both of them passed the test without missing a single question. And the elderly judge who came up and handed me my report said he had to give me extra credit on one question to get me to pass. But if I can do it, anybody can. So just let you know, it's not that hard of a test for a 14-year-old to pass it with flying colors.
So I shouldn't tell you that I aced the tech, made 92 on the general and a 98 on the extra exam.
That does not surprise me, Reed. Not at all. But again, guys, you don't need all those extra certifications, but again, they look phenomenal on a resume because they prove to your potential employers that you not only are skilled, but you're self-directed and you know how to improve yourself. And everything that you have self-trained for, they don't have to bring you up to speed on. And it may open new doors for you. It's like, hey, you've got your technician's license. We can put you on the telemetry team because we've got an opening there. Versus, hey, you don't have any skill set in there. We're going to have to train somebody else. So again, opportunities and trying to improve your resume. It's a big key of what we're trying to do here with Estra and the stuff. In addition to just having the blast launch rocket. In the end, we want you guys to make sure you get great experience and you make our aerospace industry for the world that much of a better place.
It's the only way we're going to get off this planet, guys.
True. Very true. All right.
So
Well, it's
thank you
3:30
for
now.
attending.
Yeah, I don't think we don't have any questions at this point. Please, folks, don't hesitate to go back and watch. If you missed a session, if you go back into that lobby, you can click on the view recording, and you can watch those. So there's some really good sessions out there, and those will be available to you for at least a couple of weeks afterwards. And then eventually we will upload them all to the YouTube channel. And once they're in the YouTube channel, you'll be able to watch them whenever you want to. So we'll start putting these links into some of our reference documentation, including particularly GPS as well as this session, to be able to answer all those questions for you in the future. Again, thank you very much, Randy. Thank you, sir,
Thank
as
you,
always.
Andy, and everyone that attended. We appreciate y'all support and listen and your attention.
And don't forget about the networking, the social mixer coming up next. I wasn't all that excited about it, but yesterday, um, I know this is probably an inappropriate comment, but it's like speed dating. You have 2.5 minutes to make a new friend, and then it shifts you to another person. I've talked to people from Turkey, Greece, Australia, Canada, and California. I've never heard of that place before. Anyways, they were all nice. It was really cool. By the end of it, I was exhausted because I was trying to talk so fast, and I had all sorts of new friends and new contact information, and it was awesome. I definitely recommend jumping into it. Give it a shot. Give it probably talking to 3 different people, and you'll have a lot of fun. So don't hesitate to jump in that social mixer. It's a lot of fun. For those that are in India and Greece and it's 3 a.m., okay, I'll let you go. You don't need to go to bed. But we do appreciate you staying up for this. This is being an international event and being virtual the way it is. We can't thank you enough for all the effort you got all put into this end. So thank you so much.
Thanks, everyone.
All right.
Bye.
Take care.